Today's lesson is going to be pretty simple because we're only going to tackle really the same thing, just with expanding the amount of terms that we have. So we're going to show you how to multiply polynomials today, but this will be part 1, and tomorrow you'll get to a little bit more advanced in part 2. So this is lesson 11, and there's going to be 3 different ways we're going to do it today. So the first way is how to multiply a monomial times a monomial. And remember, that would be 1 term times 1 term. Something important to remember when you're multiplying is this. When you multiply monomials, you multiply the coefficients and add the exponents. That is something that a lot of students tend to mess up and change the order of, but you multiply the coefficients and you add the exponents. So let's start going with some examples, and I think this will make a lot more sense. So example number 1. Let's do 5x squared y3 times 3x squared y2. So we said that you're going to multiply the coefficients and add the exponents. So this 5, right, is the coefficient, and this 3 is a coefficient. So we're going to multiply those and do 5 times 3, and I get 15. Then we're going to multiply the x squared with the other x squared. And that's going to give us x squared times x squared. We add those, 2 plus 2 is 4, so we get x to the 4th. And then we're going to do the same thing with the y's. So y to the 3rd times y to the 2nd is not y to the 6th. Remember, you add 3 plus 2, so you get 5. So something that might be helpful for you to do on the side is for the x's, right? X squared, that's really x times x. And you're multiplying that with another x squared, right, which is x times x. So that's why there's 1, 2, 3, 4 x's. And if you think about the y's, y3 times y2 is really 2y or 3 y's and then 2 more y's. That's 1, 2, 3, 4, 5, which is why we get y to the 5th. So that's how you multiply a monomial times a monomial. Then what we're going to look at is when we multiply, and we'll do 2 examples of these, a monomial times a binomial. Now, it is the same method. It's just sometimes you'll have a longer expression. So let's do this one. 8x to the 3rd times 4x minus 7. So notice 1 term times 2 terms gets a binomial. So this is just distribution using the same methods that we used up here. So I'm going to first multiply, right, 8x to the 3rd times 4x. So I'm going to multiply my coefficient 8 and 4. 8 times 4 is 32. Then I'm going to multiply my x to the 3rd times x. Now there's no exponent here. When there's no exponent, it's a 1, so you can always add it. So x to the 3rd times x would be x to the 4th. And now we have to do it again with the negative 7. So I have 8 as a coefficient and a negative 7. So that would be a negative 56. And then I have the x to the 3rd, but there's no x here. That means I don't add anymore, so I just recopy x to the 3rd. And there's my final answer. Some people tend to leave off that x to the 3rd, so you just have to be careful and make sure you don't leave it off. Okay, another example. 7x times 3x to the third minus 7x. This time I'm just going to underline things in color so that way maybe it don't get so messy for you. So the first thing I have to do, right, is distribute to the first term. So a 7 times a 3 gives me a 21. X, remember there's no exponent, so I add a 1. So x to the first times x to the third gives us x to the fourth. Now I distribute again. So 7 here times this negative 7 gives me a negative 49. And now I have x to the first again times x. Oh, there's nothing there. So to the first, which means it's x to the second. And there's my final answer. Okay, let's do one more. Negative 1x to the fourth times x squared minus 8x. So we have to distribute here. Negative 1. Oh, there's no number there. That means it's a 1. So negative 1 times 1 is negative 1. X to the fourth times x squared is x to the sixth when you add them. And now we have to do it again to the negative 8x. So negative 1 times negative 8 is positive 8. And x to the fourth times x, and we're missing an exponent, so add a 1. So x to the first would be x to the fifth. And there's my answer there. Okay, so now we're on the last one, and this is no different. It's just now instead of having a monomial times a binomial and only two things, you're going to have it by a trinomial, which would mean you have to multiply it 3 times. So you're distributing 3 times. So I'm only going to do one example of these since it's so similar. So we're going to do 9x squared times 10x to the fourth minus 7x to the third plus 2. So first we'll distribute to the first term. So first term to first term. So we have a 9 and a 10. So 9 times 10 is 90. Then we have an x squared times an x to the fourth, which gives us an x to the sixth. Okay, now I'll go back. We have to distribute to the second term. So we have 9 times negative 7, which is a negative 63. X squared times x to the third, which would be x to the fifth. And then we distribute one more time to this 2. So we have 9 times 2, which is 18. And then the x squared, and there's nothing here, so I just bring it over, x squared. And there's my final answer. And I totally lied and said this is going to be our last one, but I want to just show you one other thing if it looks like it has 2 variables. So we'll do one more for real, last one. Okay, let's do 9x to y3 times negative 8x 3y2 plus 4x to y minus 2y. So now I have 2 variables, but it's all the same. I'm going to distribute here. Now you just have to make sure you only stay with the same letters. So 9 times negative 8 is a negative 72. X squared times x to the third is x to the fifth. Y to the third times y to the second is y to the fifth. So I'm doing the same thing. I'm just doing it 3 times to each variable and number. So now 9 times 4 is 36. X squared times x squared is x to the fourth. Y to the third times y to the first, make sure you add it, is y to the fourth. And then I do the last term, one more. And I have 9 times negative 2 is negative 18. X squared times no x's, so I just keep x squared. And y to the third times y to the first again is y to the fourth. And there is my final answer.